Hello guys, let's take a look at sets today. You remember that when you take the square root of certain whole numbers, all right? For instance, when you take the square root of 36, it will give you 6. When you take the square root of, let's say, 49, it will give you 7, all right? Good. 6 and 7 are called rational numbers. In other words, we say they are whole numbers. So square root of 36 gives you 6, and then square root of 49 gives you 7. These answers are exact. They are whole numbers. Therefore, these numbers 6 and 7 are called rational what? Numbers. Now, when you take the square root of other numbers, sometimes they give you decimal values, and these decimal values are what we call irrational numbers. For instance, when we take the square root of 2, we have it to be 1.414213562. all right? So 1.414213562 is what we have. And this is not an exact value. This is a decimal value. When this happens, we say that this value is a decimal value, but we call it an irrational number. So since this is an irrational number or a decimal number, since there is a decimal number, its value or the answer that you obtain is not exact. When this happens, we call this as sets. So it means square root over here, square root of 2 over here falls under what we call sets. The same way, when you take square root of 3, when you take the square root of 3, let's come here, 3 gives you 1.732050808. So with this value that we have, 1.732050808, this value is not also an exact value. This is a decimal value, which is not exact. It is not a whole number, all right? It's a decimal number. So when this happens, we classify square root of 3 also under what? Sets. Therefore, when you take square root of 36, you have a whole number, 6. When you take the square root of 49, you have a whole number, which is 7. And 6 and 7 are what we call rational numbers. And then when you take square root of 2 and square root of 3, the answer you obtain are not exact. They are decimal values. So square root of 2 and square root of 3 fall under what we call sets. So that is basically the understanding of sets. When you are solving questions under sets, it means that those numbers that you can find their exact values, such as square root of 36, which will give you 6, and then the square root of 49, which will give you 7, you leave them in their rational forms. That's their exact values. That's the whole number forms. And then those that you can't find their exact values, which are the irrational numbers, you leave them in their sets forms. So it means that square root of 36 and square root of 49 are what we call perfect squares, because you can find their exact what? Values. Taking a look at perfect squares, there are several examples of perfect squares. Any number that you can find its square root and then you have a whole number or a rational number, then that particular number is a perfect square. Let's take a look at certain perfect squares that we have, all right? You can find the square root of 1, and then the answer will give you 1. You find the square root of 4, the answer will give you 2. Listen, the number over here, which is the perfect square, is written in such a way that when you obtain the answer, you ask yourself, what number multiplied by itself will give me the answer in the square root? And that is 1. 1 times 1 will give you what? 1. So square root of 1 is 1. When you come here, 2 times 2 will give you 4. So the square root of 4 is 2. When you come here, square root of 9 will give you 3. 3 multiplied by 3 will give you 9. When you come here, square root of 16 will give you 4. 4 multiplied by 4 will give you 16. When you take square root of 25, it will give you 5. 5 multiplied by 5 will give you 25. It goes on and on and on. So these are some of the perfect squares that you have to note. It goes on and on and on. You can have 36, you can have 49 that we have over here. They are all perfect squares. So note these perfect squares. So generally, what you have to note is that when you take the square root of all prime numbers, it will give you a surd. So the square root of all prime numbers are surds. So when you take square root of 2, 2 is a prime number. So the square root of 2 is a surd because 2 is a prime number. When you take the square root of 3, it will give you a surd. So when you take the square root of all prime numbers, it will give you what we call a surd. What you have to understand is that this sign that we have here is what we call positive square root. So you can't find the square root of negative values or numbers. You can find the square root of positive numbers. So let's box on and take a look at how to reduce sets to their basic form. That is simplifying sets. Let's take a look at how to simplify sets. All right, when we talk about simplifying sets or leaving sets in their basic form or reducing sets to their basic form, we mean that reduce it to the form where it can no longer be reduced, or simplify it, make it simple to the basic form, leave it in its basic form that nothing can be done to it any longer. So let's take certain examples. For instance, when you have example 1, let's take a look at square root of 8. For instance, when you take square root of 8, go through it this particular way. What perfect square multiplied by another prime number will give you 8? Think about it that way. With this, 4 is a factor of 8 and 4 is a perfect square. When we were searching for the perfect squares, we had square root of 4 and we had 2, a whole number. So when you take the square root of 4, you take the square root of 4, multiply it by a prime number, which is 2. You still get 8. So 4 multiplied by 2 gives you what? 8. Good. And you can find the square root of this 4 and obtain a rational number, which is a whole number. So moving forward, we take the square root of 4 separately, multiply by the square root of these 2 separately. Moving forward, when you take the square root of 4, look here, it gives you 2, which is a rational number, whole number. So it gives you 2. And then times this root 2. So 2 times square root of 2 will give you 2 whole number, root 2. That is what we call 2 root 2. 2 square root of 2. Since you can't leave this square root of 2 in a rational number form, you leave it in a surd form. That's what I said from the beginning. All the perfect squares will give you rational numbers. When you find the square root of all the perfect squares, it will give you a whole number, which is a rational number. But when you find the square root of all the prime numbers, they will give you sets. So 2 is a prime number. When you find its square root, it will give you a surd. So the final answer will give you 2 root 2. We have square root of 8. Search for 2 numbers that when you multiply, you will obtain 8. Make sure that one of those factors that you are multiplying must be a perfect square. So a perfect square multiplied by a prime number. 4 is a perfect square. 2 is a prime number. So 4 multiplied by 2 will give you 8. You find the square root of 4 multiplied by the square root of the 2. Square root of 4 will give you 2 multiplied by the square root of 2. 2 times root 2 will give you 2 root 2. This root 2 can't be reduced further. So the final answer is 2 root 2. And there's the final answer that we have. It can't be reduced any further. I believe you have followed. Let's take a second example. For instance, you have square root of 32. It's the same procedure. Ask yourself, what perfect square multiplied by a prime number will give you 32? Alright, search for 2 factors that when you multiply them, you obtain 32. You can go in for 2, alright, multiplied by 16, and that will give you 32. Somebody will go for 4 multiplied by 8, and that will give that same person 32. Alright, so it depends on how you want to do it, but it is much easier when you are searching for the factors. You focus on searching for a perfect square multiplied by a prime number. That will give you the answer, because basically we are trying to simplify it. So those numbers that are perfect squares, we find their square root and then we obtain whole numbers, and then those that are prime numbers, we obtain the sets for them. That is the basic idea. So with this, I will go in for 2 multiplied by 16. because I can find the square root of 16, which will give me a whole number 4. So moving forward, 32 now becomes 16 multiplied by 2, or 2 multiplied by 16. Going for 16 multiplied by 2. Moving forward, take the square root of the 16 separately, multiplied by the square root of the 2 separately. Moving forward, square root of 16 will give you 4, because 16 is a perfect square. So square root of 16 will give you 4, multiplied by square root of 2. 4 multiplies square root of 2, and then you have 4 root 2. So when you find the square root of 32, the answer is 4 root 2, or 4 square root of 2. Remember, this 2 is a prime number, so it can't be reduced any further when you find its square root. When you find its square root, you are going to obtain a decimal value, which is an irrational number. That is what we refer to as sets. So square root of 16 gives you 4, multiplied by the root 2. 4 multiplies root 2, you have 4 root 2. And this is how you reduce sets to its basic form. Let's solve another example so that you become used to or accustomed to how they are solved. Taking the third example, square root of 300. With this, it's the same procedure. Search for a perfect square multiplied by a prime number. And looking at this, what factors will multiply and then give you a product of 300? Searching for the factors, you can go in for 3 multiplied by 100. You can go in for 5 multiplied by 60, and among other options. But from the look of things, square root of 100 will give me 10, which is a whole number. So when I find the square root of 100, it will give me a whole number. Therefore, I have to go for 3 multiplied by what? 100 as the factors that I will multiply to obtain a product of 300. So square root of 300 expanding or going forward will give us 100 multiplied by 3. Because when I find the square root of 3, it will give me an irrational number. An irrational number means it will give me a set. And that is how we simplify sets. A prime number, a perfect square multiplied by a prime number. The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on and so forth. Over here, find the square root of 100 separately, multiplied by the square root of the prime number, which is the set. Square root of 100 will give me a whole number, which is 10. That is why I went in for 3 multiplied by 100. This becomes much easier because I can find the square root of 100 and obtain a whole number or a rational number. That is why I went in for 100 multiplied by 3 and not 5 multiplied by 60. So 10 multiplies the set, which is square root of 3. 10 multiplies with 3, you have 10 root 3. And this is the final answer to question 3. Let's take question 4. Take a look at it. What about if you are given 3 root 8? 3 root 8, and you are told to simplify this. It's the same procedure. This is a rational number, a whole number. And this is the set that we have, that we are supposed to simplify. So moving forward over here, you write 3 square root of the 8 over here has to go through the same procedure. What perfect square multiplied by a prime number will give you 8? 4 multiplied by 2 will give us 8. Is 4 a perfect square? Yes, because square root of 4 will give us 2, which is a whole number. And the 2 is a prime number. So we go in for 4 multiplied by 2. 4 times 2 will give you 8. 4 is a perfect square. So I go in for 4 multiplied by 2. And that is it. 3. So it is 3 root 4 multiplied by root 2. 3 square root of 4 multiplied by root 2. So you treat this one in a separate square root, treat this one in a separate square root, but they are all multiplying. If you like, you can make it 3 multiplied by root 4 times root 2. It's the same thing. So when we come here, 3 will be multiplying, square root of 4 will give you 2. So the 3 will multiply that to that whole number that you obtain over here, because this 3 is multiplying this square root, everything in this square root, and square root of 4 will give you 2. So 3 multiplied by 2, that's what we have here. Then everything will be multiplied by square root of these 2. 3 multiplies 2, you have 6 times square root of 2. 6 multiplies 2, you have 6 root 2. And this is the final answer, 2. Let's take square root of 75. With square root of 75, it goes through the same procedure. What perfect square multiplied by a prime number will give you 75? So it is a prime number multiplied by a perfect square. What pair of numbers or factors that when we multiply, we obtain 75? That is 25 multiplied by 3. 25 multiplied by 3 gives us 75. Alright? So when you find square root of 25, that gives you a whole number. So it tells us that this is the best pair of factors to go for, because 25 is a perfect square and 3 is a prime number. So this 75 gives us square root of 75 gives us 25 multiplied by 3. Moving forward, we take the square root of 25 separately, multiply by the square root of 3. Moving forward, square root of 25 gives us 5 whole number, which is a rational number, multiplied by square root of 3. 5 multiplies with 3, then you have 5 root 3. That is the basic idea surrounding sets. I believe you have followed how to simplify sets or reduce sets to their basic forms. Try and solve more examples on the reduction of sets to their basic forms. Practice is the key to success. If you want to get accustomed or used to maths or how to solve or handle figures, there is the need for you to solve more examples each and every day. Here are some of the examples that you can try your hands on to check whether you have understood what we have learned for today. So I'll put the examples here and then you try your hands on them. Alright guys, thanks for learning from my channel. I'll catch you on the next episode where we are going to look at addition and then subtraction of sets. It's a goodbye for now.